Okay, so tonight we're going to have a workshop on Docker by Naomi Pentrell. Naomi is also a developer advocate at MLab. She is a Python expert, and when she's not at hackathons, she is out being a Pokemon trainer and slaying houseplants. So she's very good at keeping your APIs and servers alive, but not very good at keeping the houseplants alive, apparently. So, round of applause for Naomi.
So welcome to our first ever session of Smooth DevOps. I'm really excited to have you here. And as Tim said, I'm going to talk about Docker and containers. And I'm not going to just talk at you. I would like you to follow along if you brought a laptop. If not, that's no problem. But it is going to be a bit more practical. So there is going to be commands that you can run to just also give you the opportunity to actually practice what I'm talking about. I'm Naomi, as Tim already said, and because he already said that, I don't really need to go further into what I do. I'm a developer advocate. That's all you need to know. Let's, to begin with, get our expectations clear. So I've got the expectation that you here as attendees don't really have much or not any knowledge about Docker and containers. And I do also kind of expect that you are somewhat familiar with the command line. So that means being able to run commands like ls and cd. If you're not familiar with those things, pair up with someone, look at someone else's computer if you can't follow along. All of the commands will be on the slides, but I won't go into detail for those sorts of things. Yeah. The goals for this workshop tonight is going to be to understand Docker and containers. Then we're going to run and download our first few containers, build one from scratch, and in the end try Docker Compose. There's going to be activity slides. As I said, this is a bit interactive. All of the slides that have this yellow badge at the top means you're expected to do something. And because this slide has one of these activity badges, I would like you to look around the room, identify someone that you haven't introduced yourself to yet, and go do that for a moment. All right. Okay. Let's continue. This was a bad idea. All right, cool. Now that you have gotten to know someone new, let's get to know something new. And let's start right away with Docker and containers. And to begin that, we're going to talk about what a virtual machine is, which is a term that maybe some of you are already familiar with. And a virtual machine is essentially an operating system that is installed on software which imitates dedicated hardware. So the way you can think about that is you have your machine. I've got my Mac right here. And I could install software like VirtualBox or Parallels on top of that. And then I could install Windows on top of that. And I'd have a Windows virtual machine in which I could run programs that only run on Windows. So that is an example that sometimes people are familiar with, even if they haven't done it professionally yet. If you've got a bigger server, the way that is set up is a bit more like the image you've got here on the right, in that you've got a big server with infrastructure, and on top of that you've got a hypervisor installed, which allows VMs to access the infrastructure underneath. And then you've got VMs on top of that. Inside a VM, you've got the operating system, so that may be Windows Server or Linux or something else. Then you've got some binaries, and you've got the app itself that you want it to run. Why would anyone want to use these VMs instead of just, buying a new server for each new application that you want to run? Well, that's essentially the point. It's a bit wasteful if you buy a new server for each application you want to run. So the idea was to use the resources in a better way, that you'd use VMs that could share the resources underneath. So then we've got containers. A container packages code and dependencies together and thus creates an abstracted, isolated, and portable app. That's also a bit of a mouthful, but we're going to go through it as we go through the entire workshop. And at the end, I promise you will have a better idea if this doesn't seem very clear right now. So the way containers work is, again, you've got some infrastructure, but this time on top of that, you've got a host operating system, and then you've got Docker installed on top of that, or some other containerization framework. And then the container itself doesn't have an operating system in it. It has some binaries, again, and it's got the app. So right away you see it's a bit smaller. And why do we want to use containers? Again, resource utilization, but also now they allow us to have more modularity, more portability, and they're also a lot faster to provision. We're going to go through each of those as we go on. But let's talk about, okay, yeah, containers are great. You've now listed some benefits, but why for me? And as a developer, I would tell you, Docker allows you to have more fast-paced development, and it allows you to develop and test without any sort of environment-specific bugs. And that's the sort of thing where you go, oh, it works for me, I have no idea why it doesn't work for my user. So with Docker, you don't really get that. And for ops, you've got that they don't have to focus on dependency management anymore, because Docker shifts that responsibility to the developer in a way. They can now essentially take care of some infrastructure to run the containers for the developers, and they can take care more of runtime tasks like figuring out analytics and things like that. And when I got started with containers and with Docker, and I think when many people get started with this, there's some sort of confusion between the two, which is why I started with talking about VMs. Because people tend to think, oh, containers, they're somewhat like VMs. They're sort of like it. That's all we need to know. And while they share some characteristics, they are quite different under the hood. So the things they share is they're both sort of isolated. They both run an application. And they both, if you're on the container, inside the container, or doing stuff on the VM, they both feel like a complete working operating system. But the way you can tell the difference is with this metaphor, the way I like to think about it. Docker uses this a lot, and I think it's a really good way of thinking about it. So if you think about houses and apartments, houses all have their own things like water supplies and internet cable that leads up to it, their own like electricity supply, their own garbage disposal program or whatever. Apartments, however, have these things mostly managed for them by the apartment complex. And virtual machines and containers are quite similar in that. So a virtual machine has a full copy of an operating system in it, along with dedicated resources like its own kernel and its own file system and things like that. And each new virtual machine takes an entire copy of that, leading to a lot of potential duplication. Containers, on the other hand, they really only package exactly what they need. And that way, another way of thinking about that is that VMs are more of like a virtualization technology. They allow the virtual machine, the technology allows the virtual machine to access underlying resources like the CPU and RAM directly, whereas containers can access the underlying resources being the kernel, the file system, things inside the operating system. So it's just a little bit smaller than the VM. On top of that, there's the thing about containers where it's a bit like cattle, whereas virtual machines are a bit more like pets. Virtual machines live longer, you take a bit more care of them, whereas containers, you spin them up, you kill them, you throw them away, you don't care about any of the data that is on them. Okay, so now let's get into Docker. Docker is one of these container frameworks. There are multiple out there, but we're going to talk about Docker here. So Docker says about itself that it's a platform that helps developers build, ship, and run any application in any environment. That means an application that runs on your computer will also run in the cloud, on a Raspberry Pi, on a server, on your friend's laptop, anywhere. Anywhere really meaning anywhere. So with Docker, a lot of the containers in the beginning were just Linux containers. Now we've also got some that are Windows containers, but most of the time we'll be talking about Linux containers. And what Docker provides is a system that allows you to run these containers on your Mac infrastructure and on your Windows host as well. They do that by essentially using a very lightweight Linux VM and then running the Linux containers inside of that. There's a bit more information on this slide that I'm not going to go through right now. If you're interested in that, take a photo or look at it later and you can read more into it or talk to me during the break. Yes? Sorry? Yeah. We'll be sharing the slides at the end or later on the meetup page. Okay. Why Docker? So I said there's multiple container frameworks. And what happened with Docker is that the community sort of really got behind that. It's managed with a common tool set. There's documentation. People write lots of blog posts about it. It was just like easy to use, and people really wanted to use it and got behind it, created a lot of resources. And it certainly also helped that it is available on all platforms so that Windows users and Mac users didn't feel left out. Okay, so much for the introduction on containers and what they are. Now let's talk about some key terms that you need to be familiar with if you want to use Docker. Starting with a Docker container. So just as repetition, Docker containers are packaged code that is packaged along with its dependencies and runs in an isolated portable environment. The way you create these Docker containers is from Docker images. And an image is something like a blueprint or a cookie cutter, which the Docker system uses to create a container when you issue a run command. People quite often get confused about the difference between a Docker container and a Docker image. And this is sort of a pun based on the famous painting of the treachery of an image by René Magritte, where this is not actually a container. It looks like a container, but this is actually just an image. So that's a way of maybe keeping it in mind that it's not a container, and there is this difference. The way to create a Docker image is through a Docker file. We're going to look at that in more detail in a bit. So a Docker file is just a file on disk that contains some instructions for creating a Docker image. And again, the Docker system, when you issue a Docker build command, will know how to create an image out of these instructions. Going a bit deeper into Docker images, a Docker image consists of layers, and you'll hear this term a lot once you build your own images. And an image is essentially, a layer is a read-only file system, and an image consists of multiple of these. So if you look at the image to the right, that sort of starts with a base image. That is, in this case, Debian. It could be any sort of very lightweight package of libraries. And then it adds Emacs in this case, and then it adds Apache, each in its own layer. And what happens to make this image a container is Docker adds yet another layer on top of that that you can write to. So that is a read-write file system on top. And when it is running, all of these different layers of single file systems turn into one unified object that Docker presents you. This is a different image of the same concept, just so that it's clearer. At the bottom, you've got an Ubuntu image, and then you've got multiple containers on top of that. But this image, there's only one of them. And then all of these top layers are read-writable, and that is the actual container. So that sort of runs on top of the image. Then there's the Docker engine, and that consists of the Docker CLI, an API for interacting with the Docker daemon, and the Docker daemon. So what happens when you issue a Docker command is that will go through the CLI. The CLI will make an API call to the Docker daemon, and the Docker daemon will negotiate with the operating system to get resources such as CPU and memory, and then actually build the containers. Now, the last bit that you need to be aware of is image registries. And those are a bit like GitHub is for code, Docker Hub is for Docker images, but there's also other container registries from Google and Azure, and you can have your own private one. But essentially, they just store your images. Other people can use the images, and you can iterate on them there. Cool. Now let's get set up with Docker. Sure. So this one? Yeah.
So are you saying like all these files right from kernel version, everything can be like overridden in a container version?
So you mean all of the files inside of these layers can be overwritten? So the image itself stays intact. When you overwrite any file that is inside one of the layers, what actually happens is it gets copied into the writable container and edited there. So the images itself don't ever get edited once they're immutable in a way. Okay, cool. Back to setting up Docker. We're not actually going to set up Docker on your machines. We're going to use a Docker playground that will ensure that you've all got the same version of Docker, and it'll just make the setup a bit quicker. So if you go to the link bit.ly/Docker playground, that's where you'll find a Docker environment. You don't need any account for this. It should be accessible without that. it will look a bit like this, so you'll know you're on the right page if you see this, just without the red bits here. Okay, and the fun fact about this is that Katacoda behind the scenes also uses containers to provide these environments for you. Okay, cool. Right, while you're still navigating around a bit, I should also mention that if you are installing Docker locally, on Linux machine, the Docker user is equivalent to root. So make sure to restrict access to that, and there's plenty of blog posts around it. I just wanted to mention it so that you're aware of the security implications. Cool, and now we're set up with Docker, and we can start running our first containers, which is very exciting. And the first one we're going to run is called hello-world. So if you want to type in Docker run hello world, and then hit enter. You should see this output. So that will be a message from Docker that just confirms your Docker environment is working correctly, which we would expect because we went to this Docker playground, right? Okay. Then let's go ahead and run something slightly more intricate. And what we're going to run is Alpine Linux, which is a very lightweight Linux distribution, and it's freely available on Docker Hub. So first we're going to pull this image from Docker Hub. We do that by running the command docker pull alpine. And this is the output you should be seeing. The first line will tell you that it's using the latest tag. You can also pull specific versions if you want to. You specify those with a colon and then the version number behind it. Then it says, okay, it's pulling from the library /alpine on Docker Hub. Then it says pull complete, and it gives you the image tag. And then it also gives you a SHA-20 256 in case you want to confirm that it's the exact image that you wanted. If you want to review the list of images that you've got locally available, you would run docker images. And you would now see these two images. You might see a few more because I think your environment comes with a few additional images. You've got the Alpine image at the top, and I would like to point out here that it's really, really small. It's 4 megabytes, so about the size of a photo. That's really cool because it's its own small little operating system almost, or it is actually. You can also see the tags here. You can see the image ID. You can see when it was created. And now let's run a command on a container that we build on top of the Alpine image. We do that by saying docker run alpine ls-l. Where alpine is the image name and ls-l is the command. Okay, and you should be seeing something like this output. So it's just listing all of the directories. And what happened in this case was we ran docker run, and that was issued with the docker CLI. That interacted with the docker daemon, which checked locally whether the Alpine image was available. And because we downloaded it beforehand, it was available. And then it built a container on top of that image and executed the command that we provided it with. And then the container exited. Now, we don't always want, we can try some other commands as well first. You don't have to try exactly these. You can try your favorite commands. Right, and as you're doing that, you should be seeing that these containers really come up fast. If you've ever tried working with a VM, they take a lot longer to spin up. Yeah, go ahead. Yes, so the question was, essentially, every time you run this command, a new container will be spun up, the command will be run, and then the container exits. Okay. Yeah, we'll go there next. So the question was whether at some point we'd want bigger containers that would remain for longer than just a few seconds. And yes, that's where we're going to go next with this. So let's go and spin up a container that is going to remain running while we interact with it. We're going to do that by saying docker run -it. The I here stands for interactive and ensures that the standard in for the container is going to remain open. And then the T stands for teletype, which essentially gives you a like terminal window. And then Alpine is the image name, and /bin/sh is where the shell is. So that is just going to give us access to the shell on this. If we run that, this is the output you should be seeing, and you're now inside the container once you run that. So you can, again, try out some commands and see what you get back. Once you're done with it, just type in exit or exit the container in a different way. If you accidentally type in exit twice, your Docker playground might terminate. So then just, if that happens, just refresh the page. Okay. Cool. And that is already it for the first bit. We're going to continue after the break with setting up a web app with Docker, and also doing some Docker Compose things. If you've got any questions, feel free to come up during the break, and I'll repeat the questions after the break as well. And I think, cool. Yeah, I hope you enjoyed the smoothies, and let's build our first web server now with Docker. And this is the web app that we're going to build. We're going to do that by just running an image from Docker Hub that I put on there already for you. So if you want to go ahead and start typing this in, and I'm going to explain each part of it. So Docker run you're already familiar with. Then we've got the -- name option. We provide a name, in this case static site. That is what Docker is going to use for the container, so that you can refer to it just as static site. Then we've got -d as a flag that ensures that the container is started in detached mode. So previously, when we were starting the containers with a command, it would give you output straight to your terminal window. In this case, it will not do that, and it will just run in the background. Then we've got -p. That is the flag that publishes ports, and in this case, it maps the port 8888 to 9000. 8888 is where it's going to be, where the web server is going to be accessible from the outside, and 9000 is the port inside the container where the web server is going to be listening on. the last bit, npentrel / smooth-docker, and then colon 1.0 is the image name. Okay. Once you run this, you should be seeing this output. It says first, going back. Yeah, so because you're in a playground, I should have mentioned that playground after a few minutes, probably for all of you during the break, will have terminated. So please refresh the page. You don't need anything from the things we've been doing before the session, before the break. So you can start right away with this command now once you have refreshed. And I'll go back to this for a moment and give you time to catch up. So just refresh the playground now and type this in. You don't need what you were working on before the break anymore. Yeah. Inside the container. Yeah, so 8888 is where we're going to be able to access it from the internet, and 9000 is inside the container, and Docker maps those two. Okay, so when you run this, you should be able to see this. Docker first says it's unable to find that image locally because we haven't downloaded it, and it then checks Docker Hub by default and pulls the image from there. It will pull the different layers here, and then provide a hash key for you to double check again, and then it'll say, okay, we've downloaded this image now, and then go ahead and run it. This 499BC62, etc., is for the container. That's the container ID in the end. I'm actually also going to run this quickly to show you how you're going to be able to access this now. This, cool. Okay, it's pulling all of that, and now it's running. So the way you can access this from here is you go up to this plus, which is like a tab essentially, right? And then you click on select port to view on host 1. This will open up a new tab for you, and here, because we said it's accessible on port 8888, we're going to type that in and say display port. So we go here and say select port to view on host 1, the third option. And then you can see the web server was successfully deployed, and you've now deployed your first web server with just one command. Cool. Right. Going back to the presentation. Okay, let's talk about what happened here. We talked about how it located the requested image. It first checks locally whether the image is there. If not, it goes to Docker Hub. It then downloads the image and creates a container on top of that requested image. Uses the name parameter to associate a name with the container. Starts it in the background because you don't want to have the output for the server generally just running there. And then returns you back to your command prompt. In the meantime, it also exposed port 8888 and linked it to the container's internal port on 9000. Yeah, if you haven't yet, go ahead and visit your website. The next thing we're going to do is we're going to stop this image and we're going to bring it back up later on, so you really need to stop this image. And the way we do that is by using the commands docker stop and docker rm. In this case, if you can make it out on the screen behind me, it uses the container ID. But because we named our container, we gave it a name, static site, we can also use those. So we can say docker stop static site and docker rm static site. And make sure to execute the rm as well. Docker stop will only stop the container and put it in the exited state. Docker rm will then actually remove the container completely from your system. If you don't do that, you may have name conflicts later. Okay. Now, you don't always just want to pull a Docker image that someone else already created. That would be a little boring after a while. So we're going to go ahead and create our own, still given my code, but that will give you an idea of how you can do that with your own code. So the code we're going to be using can be found here, and I'll give you some time to execute these 3 commands. It is first git clone, github.com/npentrel/smooth-docker.git. And then you have to change directory into smooth-docker and git checkout v1. So we're going to be working on the v1 branch. There you go. Okay, cool. This is the code that you're going to be finding in this directory now. If you look at it, so you've got a Python server that we use to serve this page. We've got a requirements file that lists the Python modules that Docker is going to install when you run Docker build later. We've got an HTML file, which is what the server serves. And the most important thing is we have the Docker file. We're going to go through that line by line. So starting at the top, it says from Python : 3.6-alpine. That uses this as a base image and pulls it from the Docker hub. So that is just like we used before, a small Alpine image with Python installed on top. Then in the next bit, we install Python modules by first copying over the requirements file into the app directory, and then running pip install -- no cache dir and -r, and then the requirements.txt file. Next up, we copy over the remaining app files then we expose port 9000, that is the one you've been specifying before, and then you specify the command that you want to be run when you run this container. And if you look to the right side, that is what that looks like in layers. So at the bottom, we've got the Python layer. Then we copy over requirements and we run pip install. And after that, we copy over the remaining files. We do it in that order because Docker is intelligent. And when you build an image multiple times, it will only rerun steps where things have changed. So if the requirements don't change, Docker doesn't have to redo that work. And that just makes it a bit quicker. Now, you also see that the top two layers, where the port is exposed and where we specify the command that is to be run when we run this container, are blue. And that is because they're not actually changing any files within the image. They're not adding any size to the image or anything. They're essentially just editing metadata for the image. Cool. And what I wanted to show you was also where you can find more information about this image. So we're going to go to Docker Hub quickly. And I will pull up the Docker file for this base image so that you know where to find that in the future. Because you can look at all of the Docker files for anything that's publicly available on Docker Hub. So we'll be looking for Python. The internet really doesn't like me. Okay, maybe we won't do this. So if you go to Docker Hub on your own time and you go to the Python image, you will see that behind each image, in parentheses, there's a link to the GitHub where the Docker file actually is and where you can see all of the commands. And these are really people that are very, very good at Docker that produce these official images. So it's quite interesting to look at them. Also a bit intimidating, maybe. Okay. Cool. Now that we've looked at all the files that we've got available and we went through the Docker file a bit, we can go ahead and build the image out of the Docker file. And the way we do that is we say docker build, and then we say -t, which specifies a tag, and then you can use your own tag. So maybe use my image or something like that so that you don't have to type this really big thing. And then as the last bit, don't forget to put a period behind the name. So space and then period. The period specifies that the Docker file is in this directory. This is what you should be seeing once you've hit enter on that. And if you're not following with the commands while I go through them, you've got the Docker cheat sheet hopefully in front of you where all of these commands are also listed. So what you see when you execute this command is that the Docker daemon goes ahead and executes all of these instructions that you've given it in the Docker file. So you can see here step 1 is it's pulling the Python image, and then it'll go through copying the requirements, etc. So you can see all of the output that these commands create there as well. And in the end, it will say it successfully built the image, and it gives you an image ID, and then also it'll say it successfully tagged it with the tag that you specified. Remember this tag, you're going to use it in just a moment to run your image, of course. So you're going to, like before, execute docker run -- name, give it the name static site. If you didn't remove your static site container before, you will be told that there's a duplicate and you will have to remove it before continuing or rename it. Then you will again start it in detached mode and specify the port mapping. And in the end now, don't specify npentrel / smooth docker, etc. Specify the name that you just assigned to the image that you built, so that you are running your own image now. When you do the build, okay, are you inside the repository, the directory that you pulled from GitHub? So you'll have to do cd into smooth-docker. Oh, into app, sorry. Yes, you do need to cd into app. That's where the Docker file is. Thank you. Okay. All right. Moving on, you can then go to port 8888, like we've done before, and see that the website is working. So you should be seeing this again. But this time, it's not the image that I created. It's something that you yourself created. And you could change the code in the folder that you're in, and it would then build a different image, and you could see your own website there. Now let's again clean up, just to always clean up behind ourselves. Again, say docker stop static side and docker rm static side. And now, no, you can do that anywhere. You don't have to be in a specific folder to do that. You can use a different port, yes. You just have to keep the 9000 because that's what the Docker file is specifying. Well, it's whatever you give, whatever you state in the Docker file. In this case, it'll be 9000 because that's what I put into the Docker file. Okay. Now the last bit, if you're not quite done with that yet, don't worry. We're not going to be using that in the next bit. The last bit is Docker Compose. And that is very useful if you don't just run one container, but you run 2 or more containers. So the sample app that we've got here is one that uses a database and ingredients that are in a database to have a random smoothie ingredient picker. And the way that is on v2, so if you've got the code checked out, you can just say git checkout v2, and then you've got to cd out of the app directory for that to work. You don't necessarily have to follow this now. This isn't very many commands anymore. So this is the infrastructure, the code diagram essentially. We've got, on the one hand, the MongoDB container, which has all the smoothie ingredients. That is connected via a container network bridge to only the web server container. The web server container is the one we've had previously in the previous example. And then we've got a laptop there where someone loads the website, which connects to the web server container over the exposed port. The laptop itself is not connected to the MongoDB container. That just separates concerns nicely because you don't really want people to connect to your database directly, probably. If you set this up manually, you would have to configure the networks on your own. And if you look to the right bottom of your cheat sheet, you can see exactly how networks are configured. We're not going to run through it, but if you do it for multiple containers, it quite quickly gets a bit annoying, and you'd want to script it. And to preempt that, Docker Compose was built so that you can have a nice declarative file that does all of this for you and sets all of this up. So a Docker Compose YAML file declares different services that you use. Those are each have a Docker file. So in this case, we've got the app service and the database service, which each list where the Docker file for it is, and they list the app server, the app container lists the port mapping like we've done before, and it also lists the network that it connects to, which we declare further down in the network section all the way at the bottom. We just say backend, and then we specify the driver bridge. That is a driver that will be used when you want to connect multiple containers that are on the same host. You do something similar for the database, where you also mention networks, and then you just list backend. And Docker Compose will take care of connecting these containers now as you specify here. One more bit to point out here: in the database container, we specify a volume. And I said in the beginning that containers are ephemeral. They're supposed to be immutable. They're supposed to be like cattle. You can throw them away, kill them, it doesn't matter. And volume sort of fills this gap. If you want to have persistent data, then you should be using a volume where you can store this data, and if the container dies, you kill it, or something like that, then your data is still going to be there in the volume. Okay, so this is based on YAML. You can also write it in JSON, but I think the general format is YAML. Yes? That depends on how you specify it. So I could just give an image name, and then it would go and find that image on Docker Hub. In this case, I specify build, and then /app and /mongo. That gives it the location of the respective Docker files. So if you look into those two folders, you will find a Docker file each. Okay, now if you did check out this v2 branch, then you can go ahead and run the commands Docker Compose build and Docker Compose app afterwards. Docker Compose build will build all of the images or pull them from the Docker Hub if they're already available. And Docker Compose app will bring all of these images up as containers. I will see whether the internet has come back so that I could show you this. Okay. I don't think I'll be able to. Okay. Cool. Right, has anyone run these two commands? No, no one? Okay. They're running. Okay, so you should be seeing some output like this. It will not terminate. So in this case, because we're not running it in detached mode, it will just at some point stop giving you more output. And it'll say something like, oh, we've imported 20 documents. If you see that, you're all good. And you can head over to port 9000 in this case to see the website. So you should be seeing something like this. Every time you refresh the website, it'll give you 5 randomly chosen smoothie ingredients. I'm not going to try and open the website. It is deployed somewhere on Heroku, but I don't think the internet is going to let me do that. Okay. now is essentially the end of the workshop. We've covered what containers and what Docker is. We've set up a bit of an environment, ran our first containers, and tried a bit of Docker Compose. There's a bit more to Docker Compose, as I'm sure you guessed. That was really just a bit of a taster. Now, someone asked me about some additional resources, and here are a few that I really liked to get started with. There's also a book out there called Deep Dive into Docker. If you really want to get to know all of the details around it, I found that to be very good. And special thanks to MLH localhost, who kindly let us base our resources on what they had already made for an event they run. Okay, now I'm not sure whether we've actually got much time for questions, because I think we were supposed to be out of here 6 minutes ago. So feel free to ask questions maybe later on the meetup page or catch me on your way out. And I think Tim has a few more final words to say.